Some of the rounds near the bottom of this list are terrifying by any normal measure. Poison bullets, fire-breathing shells, biological projectiles. They sound like they belong at the top. They don't, and we're going to explain exactly why. Because the gap between sounds devastating and actually changed warfare is wider than most people think. 10 rounds. Let's get into it. 10. Flechette rounds. Picture 1960. Vietnam is a year away from becoming the defining catastrophe of American military doctrine. And somewhere inside a DoD research facility, someone has a genuinely clever idea. What if instead of one bullet, you fired thousands of tiny metal darts, each one barely the weight of a paperclip, each one tumbling through the air at lethal velocity? They called them flechettes, and on paper, the concept was elegant. Pack a 40mm shell with 1,000 of these things, fire it over a tree line, and anyone underneath gets turned into a colander. Area denial, anti-personnel saturation. Theoretically, you could neutralize an entire ambush with a single round. Here's what the theory left out. Physics doesn't care about your theory. Flechettes are so light that the moment they hit anything denser than open air, brush, leaves, thin foliage, they deflect. Vietnam was not an open-air environment. Vietnam was jungle. The rounds that were supposed to shred through tree lines were getting stopped by the tree lines. And the ones that made it through? They lacked the mass to create reliable stopping power. A wound from a flechette could be serious. It could also be something a determined soldier walks off in a firefight. The US military ran extensive trials. The Israelis tried them in tank-mounted beehive canister rounds during the 1973 Yom Kippur War, with some success in direct-fire anti-infantry roles. But that's a very narrow use case. For general deployment, for the wide role these rounds were supposed to fill, they were quietly retired from consideration. An interesting concept, a disappointing result. A footnote. That's why flechettes are number 10. 9. Dragon's breath shells. Now we get into something that looks, on first encounter, absolutely apocalyptic. Dragon's breath is a 12-gauge shotgun shell loaded not with shot, not with slug, but with zirconium metal pellets. When fired, those pellets ignite and the muzzle blast becomes a column of burning metal, a plume of molten fire extending up to 100 feet from the barrel. On camera, in the dark, it looks like a flamethrower crossed with a dragon, which is, to be fair, exactly what the name promises. And yet, number 9, almost at the bottom. Here's the thing. Militaries don't care what something looks like, they care what it does. And what Dragon's Breath rounds do, practically speaking, is produce an impressive spectacle with serious operational liabilities attached. The range is almost comically short for any tactical application. The burning metal doesn't arc, doesn't guide, doesn't maintain coherence over distance. It blooms and dissipates. You're not setting an enemy position on fire from 200 meters. You're setting your immediate surroundings on fire while you're standing in them. The risk to the shooter, to friendlies, to cover positions is not trivial. Some special operations units experimented with incendiary shotgun loads for bunker clearing and close-quarter shock scenarios. There's documented use in improvised contexts during various conflicts in Central America. But used experimentally by a handful of units in limited scenarios is not the same as military adoption. Dragon's Breath exists in the same category as a lot of theatrical military ideas, more effective as a psychological tool in the right moment than as a tactical tool across real battlefield conditions. And psychological effect without tactical follow-through is just a magic trick. Spectacular, terrifying, practically useless. 8. Poison bullets. We're now entering the part of this list where the question stops being, does this work, and starts being, did anyone even want this to work? Poison bullets have a history longer than most people realize. The idea is simple and ancient. If the wound itself won't kill quickly enough, make the wound toxic. Apply curare to arrowheads, coat musket balls in arsenic compounds. In the late 19th century, there were serious proposals and alleged battlefield instances of bullets dipped in various toxins, the intent being that even a glancing hit becomes a potential fatality. The psychological calculus makes sense. An army that knows even minor wounds are lethal doesn't fight the same way. The will to advance degrades, medical resources get overwhelmed. But here's why it's stalled at number 8 and not higher. Timing. A poison that acts fast enough to be tactically useful tends to be chemically unstable, hard to manufacture at scale, and often degrades on the bullet before it's even fired. A poison that's stable enough to survive handling and storage typically acts slowly, over hours, days, sometimes longer. In a combat scenario, the soldier you've hit with a slow-acting toxin is still shooting back at you for the next 6 hours. You needed a faster solution than that. There's also the logistics problem. Soldiers already carry firearms, ammunition, food, water, and communications equipment. Adding a specialized chemical treatment protocol for ammunition introduces failure points at every level: mishandling, cross-contamination, friendly casualties during resupply. Cruel? Yes. Psychologically devastating? In theory. Reliably superior to simply using an adequately sized conventional round? No. Not once across any major conflict has a military demonstrated that poison-treated projectiles outperformed standard munitions in a systematic way. That's what keeps them at 8. The idea is more frightening than the execution ever was.
7. Chemical agent projectiles. Now we scale up from poison on a bullet to poison delivered as a payload. Chemical agent projectiles, artillery shells, mortar rounds, and specialized rifle grenades designed to disperse chemical agents on impact represent one of the most feared categories of weaponry in modern history. Chlorine, phosgene, mustard gas, nerve agents. The names alone carry the weight of some of the worst suffering documented in modern warfare. World War I is the reference point here. The Germans introduced chlorine gas at Ypres in 1915. The effect on Allied lines was immediate and catastrophic, not primarily in casualties, but in panic. Entire positions broke, men ran. The psychological disruption was unlike anything artillery alone had produced. And yet, if chemical rounds were so effective, why aren't they number 1? Why number 7?
Because when you study the actual casualty figures carefully over the full arc of WW1, the numbers tell a sobering story. Chemical weapons, for all their horror, accounted for roughly 3% of combat deaths on the Western Front. Artillery and small arms killed the other 97%. The gas was agonizing. It was terrifying. It reshaped how armies thought about protection and decontamination. But as a reliable instrument of military decision, of taking ground, breaking an enemy's organized resistance, winning engagements, it consistently underperformed. The reasons are operational: wind direction changes, atmospheric stability shifts. Protective equipment, primitive at first, improving rapidly, negated effectiveness within a few years of introduction. By 1918, both sides had gas masks. The weapon that seemed unstoppable in 1915 had become a factor to manage by 1918, not a war winner. Dangerous, widely banned by the Geneva Protocol in 1925 for good reason, but militarily inconsistent at the strategic level. 6. Biological agent projectiles. If chemical rounds are the nightmare you can see, biological rounds are the nightmare you can't. The concept of weaponized biological delivery via projectile, loading artillery shells, bombs, or even rifle rounds with disease vectors, bacterial agents, or viral material, represents one of the darkest chapters in 20th century military research. Japan's Unit 731, Soviet Biopreparat, U.S. programs at Fort Detrick. The Cold War-era appetite for biological weapons was real, well-funded, and deeply disturbing. The theoretical military value is significant: a biological weapon that spreads beyond the initial target area, that kills or incapacitates without requiring precision targeting, that continues to work after the battle has moved elsewhere. Strategic contamination, long-term denial of territory, force multiplication without expending additional ordnance. Why only number 6? Because the gap between theoretical and operational is massive with biological agents. The incubation period for most weaponizable diseases is days to weeks. You deploy a biological round, and your enemy doesn't drop. They fall ill later, far from the original engagement point, unpredictably, and often after your own forces have moved through the same area. The risk of blowback, literally infecting your own troops, is not a minor logistics consideration. It's an existential one. Delivery mechanisms via projectile are notoriously inefficient at aerosolizing biological material at the particle sizes required for optimal infection. The agents are sensitive to heat, UV exposure, and the physical trauma of an artillery detonation. Most of what you load in the shell is dead before it reaches the target. And then there's the international response. The Biological Weapons Convention of 1972 formalized what most military planners had already privately concluded. These weapons are strategically useful mainly as terror instruments, not battlefield instruments. The distinction matters enormously. Terror weapon dressed as military ordnance.
5. Expanding dum-dum bullets. Now we make a hard turn. We leave the exotic and the speculative and arrive at a round that worked. Worked so well, in fact, that the world decided it had to be banned. The expanding bullet, named after the Dum-Dum Arsenal near Calcutta where early British variants were manufactured in the 1890s, operates on a simple principle. Standard full-metal jacket rounds pass through a human body in a relatively clean channel. They're designed for penetration. An expanding round does the opposite. On impact, the lead core mushrooms outward, increasing the bullet's diameter, transferring its kinetic energy explosively into tissue rather than through it. The tissue damage is dramatic. A wound channel 2 or 3 times the diameter of the original projectile, hydrostatic shock radiating into surrounding organs. The stopping power, the ability to end a threat immediately, is substantially higher than FMJ. The British deployed them in colonial campaigns of the late 19th century. They worked, perhaps too well. The Hague Convention of 1899 prohibited expanding ammunition in international warfare between signatory states, not because it was ineffective, because it was too effective, deemed to cause unnecessary suffering beyond what was required to put a soldier out of action. That irony sits at the center of this ranking. Here is a round that earned an international treaty. That's impact. That's documented battlefield effectiveness so decisive that the global community decided it had to be contained. It sits at 5 and not higher because its effectiveness is primarily anti-personnel and largely negated by any serious body armor or hard cover. Against materiel, against vehicles, against entrenched positions, it offers nothing special. Its power is narrow, but within that lane, it is savage and historically verified. Number 5, and a round that changed international law.
4. Incendiary rounds. Here's where we move from rounds that are effective against people to rounds that are effective against things. And in modern warfare, things, equipment, vehicles, fuel, infrastructure, often matter more. Incendiary rounds at their core combine a penetrating jacket with a chemical payload designed to ignite on or after impact. Phosphorus, thermite, magnesium compounds. The variants are many, the principle is consistent. Get through the outer surface of a target, then burn it from the inside. The application that defines incendiary ammunition's place in military history is anti-aircraft gunnery in World War I and II. Aircraft were fabric-covered, fuel-filled, and extraordinarily vulnerable to fire. A standard round that passed through a wing might do nothing decisive. An incendiary round that punched through and ignited the fuel or structural materials was a different proposition entirely. RAF and USAF gunners used incendiary rounds routinely in ground-based and aerial combat, often loaded in alternating sequence with tracer rounds for fire correction. Anti-aircraft batteries protecting industrial targets in airfields relied on them as a primary tool. Their effectiveness against equipment, armored vehicles with fuel systems, ammunition storage, aircraft on the ground, extended the role of incendiary ammunition well beyond anti-air. In Korea, Vietnam, and multiple Middle Eastern conflicts, incendiary loads have been used against light vehicles, supply lines, and fortified positions. The limitation that keeps them at 4 rather than 3 is that incendiaries are primarily material weapons. Their effectiveness against personnel in the open is real but situational. Against hardened positions or heavily armored vehicles, they require supplemental penetration assistance. They changed how air war was fought. That's not a small thing. 3. Armor-piercing AP rounds. The first tank rolled across a WW1 battlefield in 1916. Within 5 years, every major military in the world was quietly asking the same question. How do we stop one? Armor-piercing ammunition is the answer that scaled. The design concept is deceptively simple. Replace the soft lead core with hardened steel, tungsten carbide, or a dense alloy. Reduce the profile, increase velocity. Drive the projectile through plate steel rather than across it. The physics requires extremely high sectional density and a carefully engineered tip geometry. Too blunt and the round deflects, too sharp and it shatters on impact. Getting that balance right took decades of metallurgical refinement, and when it came together, the battlefield shifted. AP rounds at the small arms level, the 30 caliber AP loads used in WW2, the later 7.62 by 51 mm NATO AP variants, gave infantry a genuine capability against light armored vehicles, gun emplacements with steel shields, and early body armor constructions. At the heavy caliber level, the development of AP rounds for tank guns defined armored warfare entirely. The race between tank plate thickness and AP penetration capability is the central engineering story of WW2 ground combat. The AP tungsten core round, later variants including AP FSDS,
The armor-piercing, thin-stabilized discarding sabot is still the primary weapon of main battle tanks worldwide. That lineage is unbroken from the first steel-cored rifle bullets of WW1 to the rounds being fired in Eastern Europe right now as this video is being recorded. AP ammunition didn't just change one engagement, it reshaped how armies designed vehicles, how infantry thought about cover, how military engineers calculated armor thickness for every generation of platform. That's why it's number 3. Proven, sustained, still defining warfare. But it's missing something that the top 2 have. 2. Armor-piercing incendiary rounds. Take everything that made armor-piercing rounds number 3. Now ask, what happens after the round punches through? With a standard AP round, the answer is a hole in the armor. Kinetic energy continuing forward. Secondary fragmentation if you're lucky. Effective, yes, but the damage is primarily mechanical. API rounds change the calculus. By incorporating an incendiary element, typically a phosphorus or thermite compound embedded behind the penetrating core, these rounds ensured that penetration was only the beginning of the event. Once through the armor plate, the incendiary payload ignited inside the vehicle, the aircraft, the equipment housing, fuel lines, ammunition storage, hydraulic systems, the things inside armor that armor was never designed to protect once a breach occurred.
The practical effect was significant. Against aircraft, API loads dramatically increased kill probability. A standard AP round might penetrate a wing spar without triggering a catastrophic event. An API round through the same path lit the fuel tank. Against armored vehicles, API loads introduced a fire element that standard AP could not guarantee. WW2 aerial gunnery is where API truly proved itself, particularly in the Pacific Theater, where the combination of speed, range, and the need for one-shot kills against fast movers made API the preferred load for multiple aircraft classes. What keeps API a 2 and not 1? It's the combination weapon. Brilliant, proven, devastating. But the number 1 slot belongs to a round that doesn't just defeat a target, it detonates inside it. 1. Explosive bullets. We've arrived, and the number 1 slot belongs to a concept so effective, so destructive, and so threatening to the entire principle of proportional warfare that it generated serious international debate before it was ever widely deployed. Explosive bullets, sometimes called explosive projectiles at the small arms scale, work on a principle that sounds almost too obvious once you hear it. Design a bullet that doesn't just wound on impact, but detonates. A round that carries a small explosive charge that triggers on contact, converting kinetic penetration into an internal explosion within the target. The results, documented in trials and limited combat use throughout the 20th century, are categorically different from any conventional round. Against personnel, the round's terminal effect is not a wound channel, it is a blast event. Against light equipment, vehicles, and unarmored aircraft, the explosive element multiplies the damage potential beyond anything a solid projectile can achieve per round. The historical military case is documented. Explosive small arms rounds were proposed, tested, and in some cases, used by multiple nations. Their effectiveness against aircraft and close aerial engagements, against light vehicles and mechanized infantry scenarios, and against personnel in fortified positions drove serious acquisition interest. And then, the international community intervened. The St. Petersburg Declaration of 1868, one of the earliest modern arms control agreements, specifically prohibited explosive projectiles under 400 grams in weight in warfare between signatory nations. The explicit reasoning, a round this destructive against individual soldiers was judged to exceed what was necessary to remove them from combat. It caused disproportionate suffering relative to any legitimate military purpose. Read that again. The world looked at these rounds and said, too effective. Not ineffective, not theoretical, too effective. That is the highest possible military endorsement, a weapon so decisive that its use required prohibition. Number 1.
If you liked this video, I'm sure you'll like this one too. Subscribe if you enjoyed this video. Our channel is small, so we are replying every comment below. Comment any suggestion for future videos. Thanks for watching.